So why is the other condition, why is the red solution not having multiple solutions? So what's the fundamental difference between the red and blue situation that makes the blue situation, the blue initial condition, would give multiple solutions? Some of them are physical, some of them are not. While the green, while the red, the first discontinuity, would not have that dilemma. What's the difference? You what?
You integrate it, so you have a integration constant.
Well, both are initial conditions that has a discontinuity, right? And just the one is on the left is higher, the right is lower. The blue one, the lower one on the left is lower, on the right is higher. Right, so what's the fundamental difference? What makes the upper initial condition unable to sustain multiple solutions?
That the upper one has the characteristics colliding together, right?
Yes.
Whereas the bottom one is not really being hit by anything.
That's the key, right? So I think we now have the key distinction here. On the upper plot, the waves, they actually collide into each other. While on the lower plot, the waves, they draw away from each other. That's the distinction. When you have waves that goes away from each other, that's a place where you could have multiple solutions. All right, so let's actually draw the waves with our so-called characteristics on this plot. Right, so in the first solution, although the solutions are constant, but the constant solution also would have characteristic waves, right? And the characteristic speed is actually this. The derivative of the flux with respect to the solution W, which is actually equal to W itself in this case, is the characteristic speed. And the characteristic speed would equal to either +1 or -1 in the first case, right? So if I draw the characteristic curves, this would be like this. This would be like 45 degrees line on the left and 45 degrees lines on the other direction on the left. So this would be the characteristic waves for the non-physical solution. While the waves for the physical solution would be like this. Still, I have the same slope on the left or right. But in the fanning region, the characteristic slopes would coincide with the contours, right? For the zero solution, the characteristic would go straight up. On the right, it's slowly sloped towards the right, and on the left, it slowly slopes towards the left. And we're saying, okay, the right-hand side is the physical solution, and the key observation is that there is no characteristics that actually is created anywhere. While on the left-hand side, the characteristic is actually emanating from the discontinuity. That's actually a violation of what we call the entropy condition. The entropy condition says that if I have a differential equation, I have a conservation law that actually has an infinitesimal vanishing viscosity in it. Then the solution at the limit of the viscosity goes to 0 is going to satisfy, of course, the integral form of the differential equation. But it is going to satisfy the equation and has no characteristics emanating from any discontinuity. Right? Does it make sense? If I just have the integral form of the differential equation, both actually are perfectly correct solutions. But if I'm looking for the limit of the solution as the viscosity term goes to 0, then the solution is not just an arbitrary solution to the integral form. It's the solution that has no characteristics coming out of discontinuities. Okay, we can also see why the entropy condition actually satisfies for this case. In this case, we have X and T diagram. We have a discontinuity over here. But the difference is that on the left, the characteristic is moving into the discontinuity. On the right, the characteristics is also moving into the discontinuity. So in this case, the characteristics are not emanating from the discontinuity. It's running into the discontinuity. It disappears into the discontinuity. And that satisfies the entropy condition. While in the green case, when the characteristics comes out of the discontinuity, that is a violation of the entropy condition. All right, make sense? Any questions on this part?
Could you reiterate what the entropy condition is?
So the entropy condition says that if you're looking for a solution of this kind of differential equation, whose viscosity term is there but extremely small, on the limit of a zero viscosity, then first of all, the solution would satisfy the integral form of the differential equation with no viscosity. I mean, if you take the limit of epsilon goes to zero, and there is no characteristics coming out of discontinuities like that. That makes sure that this solution is the correct solution and this is the wrong solution.
What makes it not physical? I'm just trying to find out where does the entropy condition come from.
What makes it non-physical is the viscosity over here, right? So if you do have a very small viscosity, the discontinuity would no longer be maintainable. If you imagine the discontinuity to be an extremely thin, very steep slope, then you would actually have characteristics that are, I mean, it's very tightly bunched into the region, but they are actually not just going left or going right. Some of them are going up, some of them are going slightly left, slightly right. So if you continue from these discontinuities, you would actually get this solution, the fanning solution, as opposed to a discontinuous solution. All right. Make sense? Okay. So the difference is that in this situation, if you have very small viscosity, then the conservation law, which have the characteristics running into the shock wave, would be working against the viscosity. Right? The viscosity trying to smooth out the discontinuity, but the nonlinear term actually just keeps the discontinuity steeper and steeper. So because the viscosity is very small, the nonlinearity wins. While in this case, the viscosity and the nonlinearity work together. The viscosity tries to make the discontinuity disappear, and then the nonlinear term takes over and makes the very steep slope even more gentle. Okay, so in this case, the green solution would be what actually happens. Right? Any other questions?